In this episode, our ant faced an even stranger foe than the carnivorous plant they previously encountered, the deadly mushroom. In the last episode, the ant successfully adapted to the emergence of these predatory plants, but now they must confront a new threat from the kingdom of fungi. Fungi are unique organisms. Unlike plants, they cannot produce their own food. Instead, they derive their nutrients from other living beings. While many fungi act as decomposers, breaking down dead organic matter, others play more insidious roles as parasites and predators. Though the presence of fungi might seem innocuous at first glance, the impact on the ant kingdoms can be profound and far-reaching. As the ants of Arthronia work to understand this newly emerging kingdom of fungi, they quickly realize the urgency of their missions. It is vital for its ant colony to learn about this organism and devise strategies to counter them before it's too late. 20 million years post-seeding, in the mid-Proto-Chaetonian period, a new species from the kingdom of fungi has emerged, one that has drawn the attention and concern of the ants. They discover a peculiar type of mushroom, one that at first glance appears ordinary but is in fact gigantic. This towering fungus is known as Mycomelopsis arboriphagus, or the tree-eating mushroom. The name itself carries profound significance. Myco, rooted in Greek, denotes its intrinsic fungal essence, while melopsis, also from Greek, evokes the sweetness of honeydew, a nod to its ability to produce tantalizing honeydew-like substances that attract various creatures. Yet, beneath the sugary facade lies a darker truth, encapsulated in its Latin epithet, arboriphagus, meaning tree-eater. This title reveals its parasitic and zombifying influence over the roots of trees, reaching a staggering diameter of 6 to 10 meters and standing 4 to 5 meters tall. Mycomelopsis arboriphagus looms over the forest floor like a monstrous sentinel. By night, its cap emits a bioluminescent spectacle fueled by a network of phosphorescent mycelium within its structure. This hunting-like lures unsuspecting prey and pollinators, creating a false sense of safety that belies the danger lurking beneath. The cap of this mushroom is broad and flat, layered with concentric, serrated rings that give it an alien-like texture. Underneath, specialized pores secrete a honey-like substance that attracts ants and other insects, fostering a deceptive symbiotic relationship. However, this sweet allure masks of predatory intent. While some ants are drawn to the nectar, others fall victim to the mushroom's lethal grasp. The sturdy stem of Mycomelopsis arboriphagus is textured and ribbed, supporting the immense weight of its cap. Its exterior is rough but coated with a slick secretion that deters larger herbivores from taking a bite. Inside, a complex mycelial network channels nutrients and sends chemical signals throughout the plant, allowing it to control the roots of the trees it infests, effectively turning them into living zombies. The fungus has evolved a unique parasitic relationship with its host trees. Its mycelium attacks tree roots, manipulating their growth to meet its own needs. It siphons nutrients from the tree while simultaneously controlling the tree's chemical outputs to attract or repel insects. Over time, the tree becomes a mere cell, drained of energy by the relentless fungal invader. In addition to its parasitic nature, Mycomelopsis arboriphagus has developed microscopic threads and sticky webs at the base of its stem and surrounding mycelium, designed to ensnare insects of all sizes. Once caught, these insects are slowly digested by enzymes secreted from the fungal filaments, ensuring the mushroom receives the nutrients it craves. Embedded within the stem and mycelium are tiny, porous structures that absorb nutrients from decaying prey, transporting them throughout the entire mushroom. The cap's upper layer is home to millions of bioluminescent spore-producing structures known as basidia. During reproduction, the cap releases luminous clouds of spores at night, carried by the wind across the mushroom moors, further spreading the fungus roots. This glowing display serves to attract night-dwelling insects in its multifaceted role as a parasite, predator, and decomposer. Mycomelopsis arboriphagus embodies the harsh realities of Arthronia. It thrives on the trees it invades, simultaneously attracting and ensnaring insects with its sweet nectar while contributing to the decomposition of dead organic matter. The ants recognize that they are not just facing a mushroom, but a complex and cunning adversary that could disrupt their ecosystem. As the ants grappled with the looming threat of Mycomelopsis arboriphagus, a far more insidious species began to emerge from the shadows. Cordignathus necromantis, commonly known as the zombie mushroom. This parasitic fungus possesses an unsettling capability, and the ants were too slow to realize the dire implications of its presence. The name Cordignathus is derived from Cordyceps, a genus of parasitic fungi known to infect insects. The second part, gnathus, comes from the Greek word for jaw or mouth, symbolizing the chilling control the fungus exerts over its host body. Meanwhile, necromantis translates to dead mind in Latin, emphasizing the zombie-like effect it has on the host as it manipulates the insect's nervous system. The fruiting bodies of this terrifying mushroom can reach heights of 20 to 30 centimeters when emerging from larger insect hosts. The spores are lightweight, easily carried by the wind or clinging to any insect that comes into contact with contaminated surfaces. Once on an unsuspecting host, the spores latch on the insect's exoskeleton, beginning the chilling process of infection by penetrating the cuticle with specialized enzymes that dismantle the insect's defense. Once inside, the spores rapidly transform into a mycelial network, a thread-like structure that invades the host body. The mycelium spreads through the insect hemolymph, siphoning of nutrients while simultaneously releasing chemicals that hijack the host nervous system. The mushroom releases neuromodulators that effectively commandeer the insect brains, turning it into a mindless zombie. The behavior of the infected insect is dramatically altered, forcing it to climb trees, branches, or other elevated surfaces. This ghastly transformation ensures optimal spore dispersal when the mushroom is ready to reproduce. Upon the death of the insect, the mushroom begins to form its fruiting body. This structure often emerges from the host's head, thorax, or back, depending on the size and anatomy of the insect. The fruiting body resembles a stalk that ranges in color from deep green to black, culminating in a spore-producing cap that resembles a small bulb. Inside this cap are sporangia, which release a new generation of spores. Once the fruiting body matures, it bursts, scattering spores into the environment to infect new unsuspecting insects, perpetuating the life cycle of Cordyceps necromantis. To protect its growth, the mushroom secretes toxins that prevent other microorganisms from decomposing its host before it has fully matured. This ensures the host remains intact long enough for the mushroom to complete its reproductive cycle. As the fungus reaches maturity, thin white mycelial strands begin to appear from the joints and cracks of the insect's exoskeleton, spreading across the body. These strands serve a dual purpose. They reinforce the structural integrity of the insect, ensuring it remains anchored to its perch even in death, and they absorb nutrients from the surrounding environment, supplementing what the fungus can extract from the host itself. This species thrives as a parasite, infecting insects of all kinds, including formidable creatures like giant grasshopper. Once infected, these insects become mere puppets, driven to spread spores and perpetuate the cycle of life for the fungus. Not only does the zombie fungus serve as killer and parasite, but it also acts as a decomposer, breaking down the very zombie it creates. Both of these fungal species present a formidable challenge to the ant kingdom, and their emergence has had profound consequences. The tree-eating fungus, while a lethal threat, also offers a tantalizing reward: nectar production that the ant colonies strive to dominate. In their quest for sustenance, the ants must fend off other predators and rival colonies eager to claim this valuable resource. However, the tree-eating fungus has a dark side. It has the power to decimate the trees that serve as both homes and food sources for the ant colonies. In an even more extreme display of its predatory nature, this fungus can ensnare ants within its mycelium, resulting in their inevitable demise. Thus, the ants face the critical challenge of avoiding the parallel zones surrounding the mycelium, where the danger lurks just below the surface. They must navigate to the stalk or climb onto the mushroom cap, evading the treacherous traps that lie beneath. In contrast, the zombie fungus specifically targets the ants, infecting them and transforming their behavior into that of mindless zombies. The afflicted ants ultimately perish, but not before facilitating the propagation of the zombie fungus and its spores. To combat the threat of infection, the ants have developed several strategies. They practice self-isolation and employ a treatment known as mutual grooming. The isolation zones are fortified with a special resin sourced from healing plants, which act as an antifungal barrier. Infected ants are quickly treated with the resin, ensuring that they don't compromise the health of the colony. Additionally, worker ants operating in areas prone to zombie fungus infections diligently coat their exoskeleton with this protective resin, creating a barrier against potential contagion. Fast forward 20 million years post-seeding, during the mid-Proto-Chaetonian period, the ants have remarkably adapted to coexist with the kingdom of fungi. They have learned to leverage the resources provided by fungal species while devising tactics to avoid becoming victims of these formidable foes. The ants of Arthronia have become adept at understanding how to adapt and foster mutualistic relationship with their environment. To survive and expand their kingdom, the ants must continually evolve, seeking to understand the intricacies of nature. They must gather, utilize, and dominate every resource available in Arthronia, with resin emerging as a vital material and antifungal agent. Certain plants have become crucial resources for the ant kingdom, and mastering their use will determine which colony will rise to prominence.